how's it going? Alright, so this video is going to be a little bit of a change of pace. With a lot of the mod videos I've done, I've had heaps of you guys out there who have followed the tutorials, done the mod successfully and had a great time, and you know, you've written in and said thanks, and guys, I really appreciate that. But what I have also had too is a lot of guys who are starting out. They've never done any mod work before, and they need a little bit of help to well, to know where to get started. So what I thought I'd do is the things I seem to be getting stuck on in particular, you know, what soldering iron do I use? Do I really need a multimeter? You know, little things like that. I mean, at the end of the day, you got to learn to walk before you can run. So I thought, yeah, I'll do well, depending on how well this is received, of course, but I'll do a bit of a series of videos, not all at once, but you know, just from time to time, on questions I'm getting asked commonly. Or if I'm giving the same set of advice over and over, instead of sounding like a broken record, and maybe I could do a short vid on it to point you guys in the right direction. So this particular video is going to be on multimeters. Now, to be honest guys, if you're experienced at modding, you know what you're doing, then you know this video is not going to be for you. This is for guys who are starting out. And so yeah, if you know all the ins and outs with these, then by all means carry on, watch something else. But if this is new to you and you don't have much experience with them, then hopefully this will offer you some tips to get you started. Now basically with these sort of videos, and actually with any of the mods I do, I try to avoid where possible using anything that's expensive or extravagant, because I want this to be accessible. I don't want to be sitting here going on about a $5,000 logic probe or something like that, because you're never going to use it again probably. You don't need it. You know, I'd like to try and find the cheapest and easiest way for you to get into it. So what I've got here is a handful of multimeters, and guys, these are all the cheapest of the cheap. These are not flash. You can pick these up on eBay, so cheap. In fact, the one I use on a daily basis is this one here. Now, I bought this thing about 8 years ago. It's beat up, it's tired, it's scratched, it's had a little door that's broken off. But the thing is even this cost me, I think it was like $19 about 8 years ago. It works and it does everything I need it to do. So you don't have to go and look at the flash brands if you're going to get into having a multimeter. But what I want to do is I want to show you just some pointers on using these and how we can apply them to the mod work that we've been doing. So I'll use this to show you how to find voltages on a Sega, or check for continuity and things like that. So again, if this isn't what you want to see guys, just write in, let me know, say nah, no help, or if you think this is useful, let me know. And you know, if you'd like to see more of these, then yeah, I want to hear from you. So alright, we'll get into it. Okay, so the first one I want to show you is continuity. And continuity is basically it's finding out where the two things are joined up. And you have to forgive me guys if I'm not going to go into the ins and outs of when a multimeter was invented and all that. I just want to keep this as grassroots as possible. So that symbol there, that is the one that we set our multimeter to if we want to check for continuity. So that enables us to see where the 2 points are joined together. Alright, so it's got a little dash with the arrow and a little line through it. So you dial it around, so your arrow's pointing at that, and then you're away. Now, guys have been asking me about multimeters, and I'll just switch over to my other one here. Here's our little dash in the air again. Okay, on this one. You notice that this has got little waves coming out the end of it. Now, this multimeter has what's called a continuity buzzer built into it. So, when 2 points are joined up, the multimeter will emit a bit of a tone. So, I hope this doesn't hurt anyone's ears. So basically, if I touch the two ends together, once I've got it set to the right thing, there we go. So you get the idea. So when these two are joined up, it beeps, okay? So Having a continuity buzzer is really helpful, and you'll find a lot of the cheap meters do have them. So when you're shopping for a multimeter, try if you can to get one that's got a continuity buzzer, okay? The reason why having a buzzer is so much more useful is because on traditional multimeters that don't have a buzzer on them, you have to look at the screen to see when there's a join. So if I touch these together, you see how it starts giving me readings. Now, there's nothing wrong with that, but it just makes life having a lot easier when you can actually listen for a tone. You don't need to look at the screen anymore. You can just basically put the two probes down on the board and just listen out for when you get a beep. So let's put that into some practical use so I can show you what I mean. Okay, so here we are looking at the bottom of a Model 1 Mega Drive board. This is a Japanese Mega Drive. Now, I've got a wire attached to pin 20, alright, and I've got my multimeter, it's set to continuity. So, first thing I want to check, if I'm not getting a picture out of it, is have I joined this wire to anything else? So what I can do is put one probe onto the where I've soldered to, and I can touch the neighbouring contacts. And I'm not getting a buzz anywhere along except for when I touch it. Okay, so first things first, that rules out that I haven't shorted this out on anything else. If I actually force this over, now I'm getting a join. Okay, so that indicates that they're touching each other. So push that out of the way, not joining anymore. So you can see with using a continuity buzzer that it's a very quick indication of what's connected to where. So it's very handy for fault finding. So if you've done one of the mods and it isn't working, well, you can inspect it with, by eye, just have a look at what you've done. But if it's hard to see or you're working with small components, then using a multimeter can be another good way to do it. So I'm just going to zoom out for a second here. Okay, so carrying on with our fault finding, and again, like I say, this is just to give you an example of what you can do with these things and how it makes life a bit easier. We've gone and checked that our two neighbouring points aren't joined up. So the next thing is our wire connected? So if I touch on pin 20 and then I go and touch to our first join, you can hear the tone going away, so therefore it is joined. So I know that this piece of wire here is good and I'm making good contact with it. So the next bit, and this is where it gets just a little bit more tricky, is if I touch the other side of this resistor, I don't know if you can, I'm hoping you can hear this, but can you guys hear that scratching sort of a noise? That's indicating that it is joined, but there's a bit of resistance. Basically the tone doesn't come through very well. It gets this funny sort of a scratching noise. I'll just try again, see if you can hear it. Okay, now at that point, if you're getting that, we'll have a look at our meter and you'll see. You can see it is connected, but it's lighting up with 75 point something ohms resistance. And so that actually tells me two things. One is it tells me that my resistor's good and it is connected, and it's also measuring the 75 ohms resistance that's on that resistor. And as this is a part of a composite mod, that's normal because we have a 75 ohm resistor and a 220 microfarad capacitor. So you get the idea, hopefully, that you can use your continuity meter to check to see if all the parts are joined correctly. As a final part of it, okay, so just to finish this up as the last part, if I come out of the negative leg of my capacitor here and I go and touch the centre of my RCA jack there, then I know that all the way along it's connected. And so if I've got no shorts and I can use my multimeter to prove that it is connected all the way through, then I know that the problem isn't actually with my wiring. I've done everything okay. So you can see how these multimeters can actually save you a lot of time as far as that goes. Alright, so we'll move on. Okay, so another quick example of how you can use your continuity tester with a buzzer just to quickly test for things. If you're doing some sort of mod where you were rewiring and you needed to know what goes where, I can pick a point and then I can run my multimeter along. Oh, there we go. So this pin here is joined up there. I can also see if it's joined anywhere else. It doesn't look like it, so I know that just by sound that I can just race over real quick and wait for a beep. As soon as I hear a beep, go back, check one by one. Oh yep, there it is. So just like that, I can find out where 2 points are joined up. So very handy if I need to put some wire links in, or if I'm just trying to figure out what's going where for maybe if I was making this machine smaller or doing some sort of other crazy project. So, alright, moving on. Okay guys, this next one's quite a quick one, and that is impedance. Alright, so here's a little symbol of our ohms, and when we're using resistors, you'll notice they're all measured in ohms. Okay, so we've got 200, 2000, 20k meters like my other one here. It's actually combined. I've got to press a little select button just to flick to what I want to meter. So you can see here this little symbol. This is an auto ranging meter, so it cycles around and it'll measure whatever, but a lot of the cheaper meters and that I've seen, like these ones here, you actually have to dial in what you want. So how this is useful is if you happen to find a resistor and you want to know how many ohms it is. So say if you've got a motherboard that's had a resistor breakdown, you can use this to see how many ohms it is. The other thing that's also useful as well is it can save you a bit of time trying to read the color coding on resistors. Okay, so just to test the resistance very quickly, or impedance, or test how many ohms. Say I've got a random resistor lying around here, and yeah, I don't want to go and look online to try and decipher what the little coloured bars mean. Basically I can put a probe on one side, probe on the other, so I'm going across it, and you can see here 75 ohms is dialing up, so I know that this is a 75 ohm resistor. So just a handy little thing that you can use just to figure out what resistors are what, because like I have quite a lot of these and sometimes they fall out of the bag, so it's good to just be able to quickly measure it. And the other thing too is if you're doing some work on a motherboard and you see a resistor on there, you can quickly measure that and see what it is. So that might be useful if you're replacing it, or if you get quite a strange value out of it, it might indicate that there's a problem with it, or again, it just gives you a bit of a guide as to what's going on. Okay, so one of the other things that we commonly use a multimeter for is checking for voltage. So what confuses a lot of people is, what do I set it to? Well, if you've got a V here with a little squiggle like that, or a little tilde there, that is AC. Okay, AC voltage, which is like what comes out of your hot point on your wall. The V here with the line and the little dots under it, that's DC voltage, so that's when you've got power and ground. So basically if you want to know whether your hot point's working or not, you'd set it over here. If you want to know if there's power inside your Mega Drive or your Super Nintendo or one of your consoles, DC voltage is commonly what you're going to be looking for. And you'll see that on meters like this, it's broken down into sort of categories, and the categories are basically how high a voltage it's supposed to be looking for. So in the likes of a Mega Drive, you're probably going to be looking for about, well, not really anything that's going to be 20 volts or over, so it's going to be 20 volts and under. So if we set it to 20, that would probably be a good place to start. But if you're getting funny readings like your yeah, it's coming up as 0 point something, then maybe set it down a little bit lower, just depending on what you're doing. So I'll show you how we can put that into practice. Now, I'll switch over to my other meter. This one here, I've got, if you look up in the corner there, see it's set to DC. I just hit my select button and I can go to AC. So DC is what we're going to be on, and yeah, we'll try and find some voltage. Now, where this is handy is I've had a lot of guys write in and say, oh, it's not easy for me to get voltage out of the voltage regulator on a motherboard. I'd like to get 5 volts from somewhere else. So with your multimeter, you can quickly dart around the board, see where you can get 5 volts, or you know, whatever you're looking for, and maybe tap out of there. Okay, so if we're going to start measuring for voltages, because like I say we're doing the Mega Drive S-Video mod, and we need to get 5 volts to run our for our S-Video for the transistors, and it's not convenient to get them out of the voltage regulator for whatever reason. We want to find 5 volts somewhere else, or even if you're doing a 50-60 Hertz switch and you want to grab 5 volts from that, but you don't want to go underneath the board. So what we can do is we're going to dart around the board and quickly check some voltages, and I'll show you why this is handy, because what I see to a lot of guys is if you want to grab 5 volts, you can grab it from some of the capacitors, but not all of them are any good, and this will be a good example as to why. So what we're going to do is with most of these motherboards, basically you can see around the edge here, this big area, that's all used as a ground, and I usually point that out in the videos as well. I'll say, oh well, you can go off to the edge and I'll show you a good ground point. So pick somewhere that's nice and convenient. Say there's a little wee solder point down here, and I'm going to zoom in a second so I can show you, but I'm going to go down here and then I use the red probe with it set to DC just to go around and just check the positive legs of the resistors, and you can dart along and check different points as well and try and see where you can find voltage that's going to be useful. Now, when you're measuring for continuity, you need, and you're checking resistance and things like that, you need to have the machine switched off. Okay, don't check for continuity while the machine's running, because you might end up shorting something out. However, when you go to check for voltage, that's when you do need to have the machine switched on. So at the moment the machine's off, but I'm going to basically flick the little switch here to turn it back on, and that's when we can check for voltages, because I know it sounds silly, but you can't check for voltage if the machine's not going. Alright, so I'm going to get you zoomed in and we'll check a few locations and see what's going on with this board. So what I'm going to do is switch machine on, and I'm going to touch onto a point that I'm quite confident is a ground, and I'm just going to come over here and check on the positive leg of a capacitor. And you've got to give your multimeter just a few seconds to settle down, because as you move it around, you know, you don't get good contact straight away. But so there we go. We've got 4.98 volts on there, and I've just measured that. Yep, 4.98 volts. So basically 5 volts. That would be good enough. I could tap onto the positive leg of that capacitor and be quite happy knowing that if I was going to use it for a 50 or 60 Hertz switch, that would be fine. Okay, so we've checked the capacitor over that side of the board, and that one there is giving us, well, basically 5 volts, so that would be fine. So what I'm going to do is, this is over the same side as the power switch that you can see here. So I'm just going to check a positive leg of a capacitor here. And that one's got 9.2 volts sitting on it. So that there would be far too much for our 50-60 Hertz switch. And what I'm going to do is just measure over to these ones over here. And these capacitors have got 2.5 volts in them, so again, that's not enough power. So you can see how using a multimeter you can quickly basically buzz around the board, test a few things, and know that you're soldering to the right places. Because that's why I always say in my videos to basically go out of the voltage regulators, because that way if I say go to this pin, it's going to have this many volts unless something's gone catastrophically wrong. But yeah, if you want to use other locations, and that's fine, but you do need to know what you're dealing with. So again, that's why yeah, a multimeter can be a real lifesaver, because you don't want to feed 9 volts into a chip that's expecting 5. That's when you can do damage. Okay, so another useful thing you can do is when you're dealing with your power packs, sometimes, I don't know, the cat or the dog get at the cables and they chew the cord, and you've got to cut it off, and you've got a got to put a new end on it. Alright, these are just examples, guys, to show you some of the things that are, you know, kind of common in how a multimeter can help you. But now you can look at this diagram here, and this tells you that the positive wire is going to the outside shell of the plug, and the negative is actually in the center. Alright, so when you've got your little socket, the center of it is negative and the outside of it is positive. But what happens when you cut the cable, and instead of having a red and black inside, you know, as in power and ground, or, you know, the common universal colours, you've got something like this, where you've got yellow and white, which is positive and which is negative. So, easy found. All we do is, these are already soldered on, so you have to have to use your imagination here. Imagine these aren't soldered because I don't know which way around it goes. Is expose some wire, and certainly make sure they're not touching. You want to keep them apart. And we can use our multimeter. If we use our red probe, we're going to check, assume that's positive. And we use our black probe there. Just try and get this in so you can see it all. You see there it's given me 13 volts. Okay? Now don't worry, this is only a 9-volt power pack and it's putting out 13, so that might alarm some of you straight away, but don't be alarmed. It's quite normal for them to put out too high a voltage, because when they've actually got a machine plugged in and drawing power out of it, the voltage actually drops down. But either way, because that gave me 13 volts, I know that where I had the red probe, the positive probe, that was a positive wire. So to explain a bit further about what I'm going on about, I'm going to do it the other way around. If I put the positive probe on the other wire, right, and a negative probe on that wire there, see, I'm now getting a negative voltage. So I'm still getting 13 volts, so I know there's power there, but it's negative 13 volts. So it's basically the wrong way around. So that's how you can tell which wire is which. Okay guys, so yeah, I think that's kind of the basics that I wanted to point out, is how to check for resistance. If you want to know what a resistor is, and if you want to know a resistor still good on your board, I've shown you quickly how to check for where you can find power on your board, how to find out which way around power is, checking continuity for the likes of broken tracks and broken wires. So I think with these few little tips, hopefully to sort of get you in the right direction as to how to use your multimeter effectively to work as a good tool for when you're doing modding. So like I say, this is the first one of these. There's a few other tools in there I'd like to talk about because I'm getting asked about them a lot. But I want to hear from you guys. Is this useful to you? Is this the sort of thing you'd like to see a little bit more of? So give me some feedback. And yeah, as always guys, thanks very much for watching. I do hope this has helped some of you out, and yeah, we'll see you again real soon.